Namaste Sarvebhya. This video I'm making just to give a short introduction on inference through the Western point of view. You will see how simple it is. First, a few terminologies which we need to understand the Western way of inference. The smallest thing which is there in an argument is a statement. A statement is simply a sentence which is either true or false, and it doesn't have any ambiguity. For example, if I say square has four sides, so this is a statement which can be either true or which can be either false. If I say something like water is very clean, so this statement is ambiguous because we cannot say if it is true or if it is false. For some, the water might be clean, for some it might not be clean. So for a sentence to be a statement, it has to be perfectly without any ambiguity, and it has to be either true or it has to be either false. It cannot be both, and it cannot be neither true neither false. It has to be one of those two. The second thing is premise. Premise are the statements which we have to assume to be true. And then we have a conclusion. Conclusion is the last statement which we make in an argument. This is the thing which we infer through the argument. Argument is the series of statements starting from premise to the conclusion. Basically, we need to use the premise in order to reach conclusion. Premise is the hetu and conclusion is the sadhya. Example of an argument. Ram has a Facebook account. This is a premise. If a person has neither a laptop nor a smartphone, he or she cannot have a Facebook account. This is also a premise. We have to assume it. Ram doesn't have a laptop. This is also a premise which we have to assume. Then we go with, then this statement is an argument because this statement follows the previous statements. And then we have the last statement. Ram has a smartphone. This statement also follows the previous from the previous premise, and this last statement is our conclusion. So this is example of an argument. First three statements are premise. The last one is conclusion, and this fourth one is just equivalent of the second statement. Let's introduce some symbols, because when we go through analyzing the validity of an argument, then it's not then using symbols comes very handy, because we don't have to write these long statements then. So these are the symbols to denote a statement. To denote a statement, we use letters like P, Q, R, S. So Ram has a Facebook account. This statement we can denote with P, letter P. Ram has a smartphone. This statement we can denote with the letter Q. And this symbol tilde, this statement means not P, means negation of P, negation of the statement P, which is Ram has no Facebook account. Ram has a Facebook account. Ram has no Facebook account is the negation of statement P. Then there is this statement up arrow. This means and, P and Q. Ram has a Facebook account and Ram has a smartphone. So this P and Q, this is true only if both P is true and when Q is true. Then only this P and Q will be true. Then the other is P or Q. This down arrow means or. If either P is true or either Q is true, then this statement will be true. Ram has a Facebook account or Ram has a smartphone. If either of these statement is true, then this P or Q shall be true. Then we have implication. So implication is the thing we can say vyapti. It's like vyapti. It's the relation like if P, then Q. Let's say P is a statement, there is rain. Q is a statement, there is cloud. Then P implies Q. This arrow means implies. P implies Q. P implies Q means if there is rain, then there is cloud. So this implication can also be either true or it can be false. In this case, whenever there is rain, there is cloud. Therefore, this statement is true. P implies Q. But if we say if there is cloud, there is rain, then this implication is not true. This vyapti is true, but the converse is not true. Similarly, here the statement P is there is smoke on the hill. Statement Q is there is fire on hill. P implies Q means if there is smoke on hill, then there is fire on hill. So this implication is also true. For an implication to be true, what we need is whenever P is true, Q should be true. That's the only condition there is for an implication. It doesn't need to be both ways. So let's learn a few more things about implication. Converse of an implication. So let's say this is the implication P implies Q. The converse of this thing is Q implies P. If there is smoke on hill, then there is fire on hill. This is simple implication, and converse of this is if there is fire on hill, there is smoke on hill. So if this statement is true, it doesn't mean that the second has to be true. It doesn't mean. Then we have contrapositive. This is contrapositive. Negation of Q implies negation of P. If there is no fire on hill, then there is no smoke on hill. Please note that this is a very important point. The first and third statement are equivalent. That means whenever P implies Q, this vyapti holds, then this vyapti will always hold every time. So this is like Anvaya vyapti and this is like Vyatireka vyapti. Whenever this is true, this has to be true. Both first and third statements are equivalent. Then we have this thing. This is bidirectional implication. It means whenever P is true, then Q is true, and whenever Q is true, then P has to be true. Example of this can be example we can think of later on, but this thing is only one directional. Whenever P is true, then Q is true. When Q is true, we cannot say that P has to be true because this vyapti is only one-sided, but this vyapti is both-sided. So this is the difference, and the important point is first and third are always equivalent statements. The contrapositive and implication are always same. Yeah, so these two statements are always true. P implies Q and negation of Q implies P. Negation of Q implies negation of P. These two statements are always true. The second equivalent statement is this one. So this means P and Q, and we negate when we negate after this. For example, let's say the statement P is Ram has a laptop and the statement Q is Ram has a smartphone. So not P and Q means it is not true that Ram has a laptop and smartphone. So P and Q means Ram has a laptop, Ram has a smartphone, and negation means it is not true that Ram has a laptop and smartphone. And this is equivalent to this statement. Not P and not P or not Q. This down arrow means or, and this up arrow means and. So when we say it is not true that Ram has a laptop and smartphone, it means that Ram does not have a laptop or Ram does not have a smartphone. So these two statements are equivalent. It is also called De Morgan's law. Similarly, if we replace this and with the or, so negation of P or Q is same as negation of P and negation of Q. So whenever this negation symbol goes inside, the symbol, the or changes to and the and changes to or. So these three type of equivalent statements we need to remember in order to apply inference. So now that these are all the things we need to apply inference, and let's see some examples. we are given that there is smoke on hill, and we are also told that if there is smoke on hill, then there is fire on hill. Now we have to prove that there is fire on hill. So let's first convert it into mathematical form. Um, let's denote this statement. There is smoke on hill, the letter P. There is fire on hill with the letter Q. So we are given. So this is an argument. We are given P. So this has to be true because we have to assume premise is true. The second thing which are given is if there is smoke on hill, then there is fire on hill. So this is a Vyapti. P implies Q. Now we have to combine both of these. This says whenever P is true, Q has to be true, and we are given that P is true, so therefore Q has to be true. So this is a valid argument. So for an argument to be valid, what we need is the conclusion should proceed from the premise. If the conclusion is obeying the premise which is on top, then this argument is a valid argument. And then there is another term which is called a sound argument. An argument is sound if the premise is true. For example, this premise might not be true. There is smoke on it. This might not be true, but still this argument is valid. If all these premises are true, then we can say the argument is valid as well as sound. There is another example. This is a much better example. So this is the same example of this argument. So we are given that Ram has a Facebook account, and we are given that if a person has neither a laptop nor a smartphone, then he or she cannot have a Facebook account. And the third thing we are given is Ram doesn't have a laptop. So let's convert this into mathematical form. So we basically have three statements here. One is Ram has a Facebook account. Second, Ram has a laptop. And third statement is Ram has a smartphone. Now let's convert. Now let's use these symbols to present our premise. So we are given P. We are given P is true. What is P? P is Ram has a Facebook account. So this is given. So we can take this as it is. We are given P is true. And we are given that if a person doesn't have a laptop, if a person doesn't have a smartphone, then that person cannot have a Facebook account. So that statement we have expressed through this symbol. Negation of Q is Ram has a laptop, and negation of R, Ram has a smartphone, implies negation of P, Ram has a Facebook account. This third statement is an equivalent of second statement. It is a contrapositive. So what happens in the contrapositive? We take the hetu. Sorry, we take the sadhya, we negate it, and we take the hetu and we negate it. So for example, here, what we have on the other side, we take it first and we negate it. And what we have on the first side, we put it on the other side and we negate it. So these statements are always equivalent. So this third statement is a direct consequence of second statement. So this is true. So now we are given that P is true. P is true, and we are given the third statement. Not given, but it's a direct consequence of second statement. So this is also true. This P is true, and P implies this thing is also true. That means, okay, first let's reduce this thing. First let's reduce this second, the thing on the right hand side. Here we apply the De Morgan's law. Whenever the negation goes inside, the and symbol turns into the or symbol. This is De Morgan's law. This is also, these both things are equivalent. We studied it here. These things are equivalent. So we can do this. So now we are given P, and now we know that this thing is also true. So it means that this Q or this other side has to be true, because we are given that P implies this thing and P is true. So That implies this this other side has to be true. So this is true. And now we take our third premise. Third premise is Ram does not have a laptop. Ram does not have a laptop, which means negation of Q. Ram does not have a laptop. Now let's see. Now we have proven that Q, this statement is true, Q or R, and we are also given that Q cannot be true. So in order for this statement to be true, it is only possible when R is true. So that's how we have proven that Ram has a smartphone. Let's see another example. This is example of an invalid argument. Let's say there is a smoke on statement P is there is smoke on hill. Statement Q is there is fire on hill. And what a person does is it says Q is given, there is fire on hill. We are given these two things. There is fire on hill, and whenever there is smoke on hill, it implies that there is fire on hill. So we are given these two things. And let's see what this person is doing. Okay, Q is given, so it has to be true. P implies Q, this is also given, and he is inferring P. So this is an invalid argument because you cannot infer this thing. You can only infer P is true if the implication is the other way. In this case, this is an invalid argument. Let's see this thing. These are the three premises, and we have to prove this thing. So we are given P and Q are true. This statement can only be true if both P is true and both Q is true. So from this, it directly implies that P has to be true and Q also has to be true. Then only this statement will be true. So the second statement is an implication of first statement. Third statement is also an implication of first statement. Then we take the second premise, which says P implies negation of. So this statement is same as the tilde sign. This means negation. So P implies this thing. And since P is true, we can say the other side is true. So this other side has to be true. Now we use the De Morgan's law. The negation goes inside and the and symbol turns into the or symbol. And we are given that Q is true. So we are given Q is true, and this statement is also true. So this statement can only be true if either this thing is true or either this thing is true. Now the first part cannot be true. Why? Because in the third statement we are saying Q is true. So that implies that the second statement has to be true. So this statement is true. Now we are also given that S implies R. S implies R. So what does it mean? S implies R also means negation of R implies negation of S. Negation of R implies negation of S. And since negation of R is given, we can infer negation of S. So this is a valid argument. So this is proven. Similarly, this thing, negation of, so this is the premise and we have to prove that B is true. So this thing is given as it is. And this is a premise. So if we take a contrapositive of this, it will mean negation of C implies A or B. 1 second. So contrapositive of this thing will be negation of C implies A or B. So we are given that not C. So we are given that not C. That implies this has to be true, A or B. So this is the statement, A or B. Now we are given that A cannot be true. So for this statement to be true, what has to be done? B has to be taken true. So this is also a valid argument. So that's how in Western thinking the inference works.